So in the previous example, we saw how to simplify a factorial, and here's the kind of equation where you might need to do that. This will happen kind of regularly when you get into permutations and combinations, which are coming very soon. So we have n factorial over n minus 2 factorial equals 42. Now, basically the only thing that can cancel a factorial is another factorial. We need to get these to match up. The n factorial is the bigger one, so if we take that apart, we can pop an n off the end of it, and then we can pop an n minus 1 off the end of it, and that leaves us with n minus 2 and everything after in our factorial. Why did we stop there? Because we want to cancel against the n minus 2 factorial in the denominator. So do that. The factorials cancel, wonderful, and we get n times n minus 1 equals 42. How do we solve that? You could eyeball it, I suppose, if you were very keen, but I'll pretend I don't see the solution that way, and we'll multiply this out. N squared minus n, take the 42 over, equals 0. Now it's a quadratic. What two numbers add up to negative 1 and multiply to negative 42? Time's up. It's n plus 6 and n minus 7. Now, that gives us two solutions here. We could have n plus 6 equals 0, which means that n is negative 6, or we could have n minus 7 equals 0, which means that n is 7. Are both of those answers valid? They're both valid if this was just a quadratic, but there's something else to this problem. Whatever result we have to be able to put it into a factorial, and at this level we can't do a negative number inside a factorial. In fact, you've probably been told that that's not allowed at all. So the negative 6 solution is actually no good. We will reject that. And the only valid solution will be that n equals 7. That means up here, if n is 7, they're saying that 7 factorial divided by 7 minus 2 is 5 factorial equals 42. You can check that either on paper or with a calculator and confirm that it really is true.